We see giant turbines everywhere today, but their journey from a simple survival tool to massive energy generators is full of wild twists. To understand how we got here, we have to rewind the clock about 1,000 years. Back then, the windmill wasn't about electricity. Its entire purpose was to help us eat, turning grain into flour and flour into bread. The engineering started with the post mill. The entire wooden building balanced on a single massive central post. The catch? To face the wind, you and your neighbors had to physically push the entire building around. It was back-breaking work. That evolved into the smock mill, a total game changer where only the roof, the cap, had to turn, allowing the structures to get bigger and stronger. Finally, we got the tower mill, built from brick and stone so they could reach higher to catch consistent winds. But here's the wildest part of this early history. These peaceful machines had a terrifying military use. Medieval armies would sometimes use them to launch hives of angry bees over castle walls during sieges. No joke. Fast forward to the late 1800s. The Industrial Revolution is hooked on coal, but it's filthy and expensive. A few brilliant minds looked at these ancient mills and asked, could this old idea solve our modern problem? This sparked a global wave of innovation in the 1880s. In 1883, an engineer in Vienna hooked a windmill to a generator at an exhibition. In 1887, a Scottish professor lit up his holiday cottage. In France, an inventor was selling charged batteries. Then, in 1888, an American named Charles Brush built an absolute beast of a machine in his backyard in Ohio. It powered 350 lights in his mansion, proving that wind electricity actually worked. But the most emotional impact came from the Arctic. In 1893, explorer Fridtjof Nansen took a windmill on his ship to the North Pole. In the crushing dark winter, he wrote that the electric light was a lifeline, acting on their spirits like a draught of good wine. Moving into the 20th century, the rise of aviation turned wind power from a miller's trade into a science. Paul Lecour in Denmark began using wind tunnels to study aerodynamics, discovering that fewer, sleeker blades were more efficient than canvas sails. Then came the golden number, 59.3%. In the 1920s, German physicist Albert Betz calculated that no turbine can capture more than 59.3% of the wind's kinetic energy. Why? Because if you took 100%, the air would stop dead behind the blades and block the fresh wind from coming in. This is Betz's law, a hard physics limit that gave engineers a target to chase. After World War II, the pursuit of this efficiency split the industry into two competing philosophies: the German approach, led by Ulrich Hutter, high-tech, complex, lightweight, and aerodynamic. Think of it like building a race car. The Danish approach, led by Johannes Joule, simple, heavy, and robust. Think of it like a tractor. This was a grassroots movement, symbolized by the Timvenkraft turbine. Built by teachers and volunteers for decades, this was a niche technology. Then in 1973, oil embargo hit. Gas prices skyrocketed and the world panicked. Governments needed alternatives fast. The proving ground for this showdown was California in the early 1980s. The state offered huge tax credits, creating a wind rush in places like the Altamont Pass. It became the world's largest laboratory for wind energy, with roughly 17,000 turbines installed by 1990. So, who won? The race car or the tractor? The results were undeniable. While the complex American and German designs broke down, the rugged, simple Danish designs just kept running. Their built-like-a-tractor philosophy became the blueprint for the modern wind industry. With the winner decided, the 1990s became a race for scale. Germany passed laws to become a wind hub, and Denmark built the world's first offshore wind farm in 1991. The jump in power is mind-boggling. 1888, Charles Brush's machine powered 350 light bulbs. 1980s, a standard turbine generated 55 kilowatts. 1993, we hit the 1 megawatt milestone, powering 300 homes today. A single offshore giant generates over 15 megawatts, an increase of nearly 300 times the power of the 80s machines. Just one of these today can power over 16,000 homes. From grinding grain and launching beehives to powering our digital world, the windmill has constantly reinvented itself. the pioneers figured out how to use the wind to light up our world. It makes you wonder, what challenge will this technology solve next?